In the next couple of episodes, we're going to start to introduce gas laws. What is a gas law? A gas law is a generalization that describes, in mathematical terms, the relationships among the amount, pressure, temperature, and the volume of a gas. So there are four variables in gas laws: the amount of gas, pressure, temperature, and volume. The amount of gas is going to be expressed in number of moles. Temperature, we know what it is. Volume, we know what it is. So what is pressure? Pressure, by definition, is the force divided by the area that the force applies on. So it's the ratio between force and the area that the force applies on. The common unit is atmospheric pressure, ATM, millimeter mercury, 1 ATM equals 760 millimeter mercury. We also see torrs, PSIs in the US. Well, torr is about the same as a millimeter mercury. 1 millimeter mercury is very, very close to 1 torr. 1 ATM equals 14.7 psi. However, in this class, we focus on ATM, atmospheric pressure, and millimeter mercury. Why does a gas have pressure? Where does the pressure of a gas come from? Well, the pressure of a gas is caused by the collisions of the gas particles on the wall of the container. Gas particles move very fast. They have the highest kinetic energy. So when they collide on the wall of the container, it causes pressure. Talking about gas pressure, we have to discuss a little bit about a piece of device which is called barometer. A barometer is a device that is used to measure the atmospheric pressure. Have you ever wondered why 1 atmospheric pressure equals 760 millimeter mercury? Doesn't this equation look strange to you? ATM is a pressure unit, atmospheric pressure. Millimeter mercury, is a length unit. It's a unit of length. Mercury is a substance. How come the length unit plus a substance becomes a pressure unit? Well, that question will be answered after we look at this mechanism of a barometer. All right, this is a simplest barometer, a drawing of a simplest barometer. So what do we have here? We have a long tube. I'm going to draw it here. Very long tube. What do we do in this experiment? We fill it up with mercury, a liquid metal. Fill it up with mercury, so full of mercury here. Once it is full, we cover it up. So inside is a full tube of mercury. What we do now, we reverse it up, down, put it into a mercury reservoir. Okay, once it is in the reservoir, you remove, take the opening end is here, for example, you remove, take away the cover of the opening end. Now, if this tube is long enough, the mercury inside is going to fall. When it falls, it creates a vacuum here. There's nothing there. Okay. Interestingly, the mercury inside the tube will not fall all out at a certain height, at a certain point, it is going to stop falling. It's going to stay there. Why? Because there is an atmospheric pressure is pushing on the surface of the mercury. It is supporting some length of the mercury liquid in the tube. All right. One atmospheric pressure on the surface of the liquid reservoir of mercury can support 760 millimeter height of mercury column. That is why 1 atm is claimed to be 760 millimeter mercury. Well, if you change the liquid, if you do not use mercury, you can use any other liquid. However, mercury is the heaviest liquid available. If you use other lighter liquid, the height that the atmospheric pressure can support will be very high. That tube needs to be very long. And that is why mercury was chosen at the beginning. All right, 1 atm equals 760 millimeter mercury. Now, let's talk about the first gas law in this chapter, the Boyle's law. The Boyle's law states that the pressure and the volume of a gas are inversely related if the temperature and the amount of gas are not changing. So for a fixed amount of gas, if the temperature stays constant, then the pressure and the volume of the gas sample are inversely related. For example, there's a gas sample. At the initial state, the pressure is P1, the volume is V1. Then condition changes. It changes to a new set of condition. At a new set of condition, the pressure becomes P2, the volume becomes V2. During this change, the temperature didn't change. Okay, and this is the same gas sample. According to Boyle's law, pressure and volume are inversely related. That means P1 over P2 equals V2 over V1. Mathematically, that means the pressure and the volume are inversely related. However, this is not the most common way how Boyle's law is expressed. Mathematically, this is the most common way you see how Boyle's law is written. P1 times V1 equals P2 times V2. Well, these two mathematically are the same. If you do a cross multiplication, you're going to get P1 V1 equals P2 V2. All right, same thing. So let's jump into a practice. Oh, no, not yet. So this picture, this drawing shows you the inversely related relationship between the pressure and volume of a gas sample. So in the cylinder, the initial situation, the pressure is 100 millimeter mercury. The volume is 8 liter. Then condition changed. You press it down. The volume becomes 4 liter. Volume is cut in half. Well, the pressure will double. Inversely related. When pressure doubles, volume becomes half of the original volume. Now pressure doubled again, volume is cut in half again. That's Boyle's law. Pressure and volume are inversely related. Let's do a practice. A gas sample occupies 12.4 liter at 23 Celsius, and the pressure is 0.956 atm. What volume would occupy now at 1.2 atm, assuming the temperature is not changing? All right, temperature stays constant, Boyle's law. All right, let's figure out at the beginning the pressure and the volume. So P1 at the beginning is 0.956 atm and V1 is 12.4 liter. Later on, condition changed, pressure changed to 1.20 atm, and the question is asking you, what is the volume of the sample now? Okay, Boyle's law, P1, V1 equals P2, V2. Let's isolate V2 out. That's what is asked. Okay, so let's divide both sides by P2. The left become P1 V1 over P2. P1 is 0.956. V1 is 12.4. 12.4. P2 is 1.20. All right. I did not do the calculation, but the answer should be very close to 10, somewhere very close to 10. It's going to be liter. All right, let's see the number. All right, 9.88. 3 sig figs. 3 sig fig here, 3 sig fig here, 3 sig figs here. So your answer need to keep 3 sig figs. 9.88 liter. Based on Boyle's law, if the pressure on 30 milliliter of gas is changed from 1 to 2, pressure doubled, what will the new volume in milliliter will be? Okay, when pressure doubles, what happens to the volume according to Boyle's law? All right. Pause the video, answer the question, and come back to check the answer again. Here is the answer. Pressure doubled, volume will be cut in half. They are inversely related. So the volume should be 15.0 milliliter. Did you get it? All right, see you next time.